Today we're going to add one more vocabulary word to our statistics. It's standard deviation, and before we talk about that, we're going to define the word deviate because it's important for knowing what that means. Now, deviating means to stray away from an expected value or location. You might be, say, standing on a path, walking down a path, and if you deviate from it, you're going off to the sides of that. Now, this could end up being very important in a lot of situations. Let's give you a real quick example. Let's say you were in charge of filling bags of M&Ms. Now on that bag it has an amount of M&Ms that are expected to be there. Let's say you have 1 ounce of M&Ms in this bag. Now that is an average. Those bags are not exactly 1 ounce. Sometimes they're a little bit less and sometimes they're a little bit more. But if you got a bag that was a lot less, then you would be upset about that. So standard deviation measures how far something deviates on average, and in a situation like this, you would want it to deviate a small amount so that you could expect to have 1 ounce of M&Ms in your bag each time. So if you have a large standard deviation, that means it deviates a lot. You wouldn't want this in the case of the M&Ms. If you have a small standard deviation, that means it deviates only a small amount, so it stays right close to its average to the mean. Next, we're going to do an example of calculating standard deviation. We're going to first do it by hand, and then we're going to do it by computer. I've written the steps down here for calculating it by hand, and you'll notice that it is quite extensive. If we had a lot of data points, this would end up taking us a long time to do, so most of the time this will be done on computer. But I wanted to show you how to do it once by hand. So first, we need to find the mean, because if we're going to figure out how far we deviate from the mean, we need to know where the mean is. So we're going to add these together, 12 plus 19 plus 22. 12 plus 19 plus 22 gives us 53. And then we're going to divide that by 3 to get us a total of X bar, our mean, equals 17.6 repeated, so I will round that to 17.7. All right. Next, we need to figure out how far each data point is from the mean. That's kind of the deviation part. We're deviating from that 17.7, and you can see that. How far is the question? So we're going to do 12 minus 17.7 to figure out that this one deviates by 5.7 below. 19 minus 17.7 gives us 1.3 above. And 22 minus 17.7 gives us 4.3 above. This is how far we deviate. Okay, we're going to take each of those data points and we're going to square them. So negative 5.7 squared gives us 32.49. 1.3 squared gives us 1.69. 4.3 squared gives us 18.49. So we're done with that step. Now we're going to add these values together. So these three added together, 18.49 plus 1.69 plus 32.49 gives us a total of 52.67. We're done with that step. Next, we're going to divide by the number of data points, which is 3 in this case. So 52.67 divided by 3 is 17.6 if we round it. So 17.6. We're done with that. And then we're going to take the square root of this value. So the square root of 17.6 gives us a total of 4.19. We'll just round that to 4.2. So our standard deviation is 4.2, and we're done with calculating that. So you can see this is pretty extensive. We'll do it on the computer again in just a second. All right, what does this tell us though? So we expect to be at 17.6. That's our mean, or 17.7, sorry. But we know we deviate from it. The standard deviation tells us that we expect to deviate by about 4.2 above it as well. So that would give us kind of an area where we expect to be in from here to here, and we'll use that for our analysis and when we do some projects and talk about real-life scenarios. All right, let's go over to the computer and see what it looks like there. So I've opened up here our Google Sheets spreadsheet, and I've typed in the 3 values that we used for our standard deviation earlier, 12, 19, and 22 right here. In order to get Google Sheets to calculate the standard deviation, I'm going to go to a blank cell and I'm going to type in the command. This is important to remember, so go ahead and write this down. It's equals STDEV for standard deviation, and then P for population. And we're going to open a set of parentheses and we're going to highlight all the numbers we want to calculate the standard deviation for. So I'm going to go ahead and go to this 22. I'm just going to click and drag to highlight those 3 numbers, and you can see it fills it out right there, and that color coordinates with this color down here. We're going to close the parentheses, hit enter, and we get 4.2 when we round it. So we can see that it's far, far simpler and faster on the computer. That allows us to get to the point where we can analyze and use this instead of just sitting there and calculating. Thank you very much.